Hello, I am Geronimo Farré, and Dr. Wellens and myself have prepared a series of videos in relation to the types of ventricular preexcitation. In this first video, we will explain the concept of typical preexcitation. The conditions to develop ventricular preexcitation are three. First, the existence of an accessory atrioventricular pathway that conducts in atrioventricular direction. Second, that the atrioventricular conduction times via the accessory pathway are short, less than 120 milliseconds. 3. That the atrioventricular conduction times via the normal AV node His pathway are longer than over the accessory pathway. The greater is this difference in atrioventricular conduction times, the more evident preexcitation will be. In patients with typical preexcitation, we can calculate the atrioventricular conduction times via the accessory pathway and via the AV node His pathway. The atrioventricular conduction times via the accessory pathway are determined by the duration of the PR interval, in this example 80 milliseconds. The delta wave represents the time interval during which there is preexcitation, that is to say, the period of ventricular activation via the accessory pathway. The atrioventricular conduction times via the normal AV node His pathway are equal to the summation of the PR interval plus the delta wave durations, in this example 130 milliseconds, 80 milliseconds of the PR interval and 50 milliseconds of the delta wave. Ventricular preexcitation is typical when the PR interval is short and there is a wide QRS complex with a slow initial forces that we call delta wave. The duration of the PR interval depends on the atrioventricular conduction times via the accessory pathway. The PR interval will be short if the AV conduction times via the accessory pathway are less than 120 milliseconds. An evident delta wave will be present if the atrioventricular conduction times via the accessory pathway are shorter than those over the normal AV node His pathway. Because right-sided accessory pathways are relatively close to the site of impulse formation, that is the sinus node, they usually result in very evident patterns of preexcitation because the AV conduction times are usually the shortest AV conduction times produced by accessory atrioventricular pathways. However, left-sided accessory pathways are relatively distant from the site of impulse formation, from the sinus node, and therefore in sinus rhythm they usually result in lesser degrees of preexcitation than right-sided accessory pathways, and even occasionally preexcitation might be non-evident in people with left lateral accessory pathways. This is an example of typical ventricular preexcitation in a patient with a right-sided free wall accessory pathway. Remember that we consider typical a preexcitation when the PR interval is short, equal to or more frequently less than 120 milliseconds. The QRS complex is wide, equal to or more than 120 milliseconds, and there is a visible slurring of the initial forces of the QRS complex, what we call a delta wave. In this example, the PR interval was 110 milliseconds or 0.11 seconds. The QRS complex had a duration of 0.14 seconds or 140 milliseconds, and the delta wave had a duration of approximately 60 milliseconds. And if that is the case, this implies that the atrioventricular conduction times via the normal AV node, his pathway should be around 170 milliseconds. Via the accessory pathway, we have postulated 55 milliseconds from the sinus node to the atrial insertion of the accessory pathway, 55 additional milliseconds to cross the accessory pathway to reach the right ventricular myocardium. And via the normal pathway, we have postulated 45 milliseconds from the sinus node to the entry of the AV node, 80 milliseconds to cross the AV node, and 45 milliseconds to reach the terminal Purkinje network via the bundle branch system. In this case, preexcitation is very evident or typical because the atrioventricular conduction times via the accessory pathway are 110 milliseconds, via the normal pathway are 170, and the difference between these two values, 60 milliseconds, is exactly the duration of the delta wave. So we have preexcitation during 60 milliseconds. You are advised to follow the rest of the videos on ventricular preexcitation. Thank you very much for your attention.